Hi, let's take a look at the how the transistor functions in active mode. Now, we've already said that in the active mode, the base collector junction is reverse biased, right? While the emitter base junction is forward biased. So, what does that mean in terms of the voltages? What that means is we want our VBC to be less than zero point 0.5 volts, which is the forward voltage of our diode, and we want VBE to be approximately equal to zero point 0.7 volts because it's forward biased, so the voltage doesn't change very much as the current changes through the diode. Now, of course, notice what I've done here for VBC, which I've done in the previous cases also, is that I've said VBC is less than zero point 0.5 volts. But zero point 0.5 volts is not really where it starts to get cut off. It's not a very straight line, right? It's not a hard boundary. So sometimes you could write VBC is less than zero point 0.4 volts for forward bias and things of that kind, but that's all right. Okay. So now in the active mode, how does the transistor operate? So let's build a model for that. So we'll do a similar thing like we did in the cutoff mode. So you have the base here, you have the collector here, and you have the emitter here. Okay. And what we are going to do is we are going to draw in the forward bias, this base emitter junction can just be represented by a voltage drop, right, which is 0.7 volts. And when you have this voltage drop, there will be some current going into the base called IB, and the current IC depends on IB. Okay, so you will have something like this. So you have a current dependent current source, and the current here is dependent on the current IC is dependent on IB and is beta times IB, where beta is a large number and it could be something like 100, sometimes 50, something around that. Okay. What is if this is the case? If so, you can see that if this is IC, and you can see that the entire IC is flowing through this current dependent source. So beta IB is equal to IC. Okay. What would be the current IE then? This current. You can very easily see that IE is equal to IC plus IB in this model, which is equal to beta plus 1 IB, which is also equal to beta plus 1 over beta IC. Okay, and it's fairly straightforward to see if beta is very large, then IC is almost equal to IE. And the reason why that is because uh, there are two currents that contribute to IE, right? And if this current is much smaller than this current, then IC is equal to IE. And IC is much larger, or IB is much smaller than IC when beta is very big. So as beta becomes bigger and bigger, IC becomes equal to IE. Okay, hope that makes sense. So this is the active mode of the BJT.